Hey everyone, welcome back to AI Podcast. Today we're going to be diving deep into large language models. You know those AI systems that can write like, well, a human.
Yeah, think ChatGPT. It's amazing how these tools can generate different creative texts and translate languages just like that. Even answer questions in a way that feels like you're chatting with a real person.
It really is mind-blowing. But how do they get so smart? Well, that's exactly what we're breaking down today, the whole process of training these LLMs.
Yeah, it's kind of like building a super brain for language, one step at a time. So we'll go through the 5 stages of this training pipeline, and then we'll look at this model called DeepSeek R1. It does things a little differently, get some really interesting results.
Okay, let's start at the very beginning. Stage 1, data collection and pre-processing.
Imagine trying to teach someone a new language, right? But instead of a textbook, you give them the entire internet. That's sort of what we're doing with LLMs. The amount of data is just massive.
We're talking web pages, books, academic papers, even code and social media posts. It's all carefully selected.
But it's not just about throwing a ton of data at the AI. It's like building a giant, super organized library. That's where the pre-processing comes in.
So it's not just quantity, it's quality too.
Exactly. Think of it like this. We have a team of super efficient librarians working behind the scenes, removing duplicate information, standardizing the format, and breaking the content down into bite-sized chunks, making the data pristine, ready for learning.
Okay, so now we have this massive, organized library of information. What's next?
Time to build the brain. Stage 2, model architecture. And most LLMs today are based on something called the transformer architecture.
The transformer. It's been making waves in the AI world since, what was it, 2017?
Yeah, a real game changer. Imagine a detective, carefully analyzing a witness statement, highlighting key phrases, connecting the dots to see the bigger picture. That's basically what the transformer does with language, using a mechanism called self-attention.
So the AI is like a superpowered detective, figuring out how the language puzzle fits together.
Exactly. And to make sure the AI doesn't get confused by the order of words, we use something called positional encoding. It's like giving each word a little tag based on where it is in the sentence.
So it's not just understanding the words themselves, but their order and how they relate to each other.
Right. And then there are feed-forward networks. These help the AI extract deeper meaning. Finding patterns from the data, it's like the detective's intuition, piecing together clues, making inferences.
Wow, it's like a whole team of detectives working inside the AI.
That's one way to put it. And to keep everything running smoothly, we use techniques like layer normalization and residual connections. Help stabilize the training process, make sure the model learns effectively.
So a well-oiled machine learning process.
Exactly. Okay, we've built the brain, prepped the library. Now it's time for the AI to hit the books. Stage 3, pre-training. The model dives into that huge data set and starts learning.
This is where the magic happens, right? The AI reads the data over and over, trying to predict the next word in a sentence.
Exactly, like giving the AI this giant jigsaw puzzle of language. And it has to figure out how the pieces all fit together. The more it practices, the better it gets at understanding the nuances of language.
I bet that takes a ton of computational power.
It does. We're talking supercomputers working 24/7 using specialized chips. TPUs, GPUs, a massive undertaking, but worth it.
Okay, so after all that training, I imagine the model's pretty impressive.
It's definitely learned a lot, but it's still a bit, rough around the edges. Think of a talented artist that needs some refining. That's stage 4, fine-tuning.
Fine-tuning, like taking raw talent and shaping it into a masterpiece.
Exactly. There are different ways to fine-tune, depending on what we want the model to excel at. One way is supervised fine-tuning. We train the model on specific tasks, like translation.
So if we want the AI to be multilingual, we give it tons of translated text examples. Let it learn the patterns.
Right. Then there's domain-specific fine-tuning. Tailoring the model for specific fields, like medicine, law, helps it understand the specialized language.
Like giving the AI a crash course in med school or law school.
Exactly. And then there's instruction fine-tuning, teaching the model to follow instructions, complete specific tasks.
So we could say, write a poem like Shakespeare or summarize this paper in 3 bullet points.
Exactly. These techniques allow us to create LLMs that are super versatile, helpful in so many applications.
We're almost there. But before we unleash these models, there's stage 5, alignment and safety measures.
Super important. We need to make sure these LLMs are safe, ethical, and beneficial. Make sure they use their powers for good.
We don't want our super intelligent AI detectives going rogue.
Definitely not. One powerful technique is reinforcement learning from human feedback, or RLHF. It's like a teacher giving feedback. Human annotators rank the model's responses, and it learns from that feedback to improve.
Constantly learning, refining its responses based on human guidance.
Right. We also use constitutional AI. building in guardrails, like rules of conduct, keeps the model on track.
So no offensive language, no spreading misinformation.
Exactly. And then there's adversarial testing. We challenge the model, with tricky situations to see how it reacts. It's like a stress test to make sure it's robust, can handle unexpected things.
Okay, we've covered the 5 stages, from data to safety measures. It's complex, but it sounds like a well-established process.
It is, but you mentioned earlier some LLMs do things differently, like DeepSeek R1. It has some interesting advantages because of its unique training methods.
That's where things get really interesting. What sets DeepSeek R1 apart?
Well, for one, the training data itself. While many LLMs use a mix of internet data, DeepSeek R1 focuses on high-quality curated data sets.
So, being picky with its reading material?
You could say that it prioritizes technical domains like scientific papers, code repositories, gives it a specialized edge in those areas.
An AI expert in specific areas? That's fascinating. Does it stick to English or?
Nope, DeepSeek R1 is trained on multilingual datasets, much better at understanding and generating text in multiple languages. Quite the polyglot.
Wow, impressive. So, specialized knowledge, multilingual. What about the model architecture itself? Traditional transformer.
It builds on the transformer, but DeepSeek R1 adds some innovative twists. One is mixture of experts, or MOE.
Okay, AI jargon alert. What's Mo all about?
Instead of using all parts of the model for every single word, it uses specialized experts for different tasks. It's like having a team of specialists on call.
So getting more work done with less effort.
Exactly. Improves efficiency, reduces computational overhead. One reason DeepSeek R1 is more cost-effective to train.
Ah, so that's one of the secrets. Any other architectural tricks?
Another one is long context training. DeepSeek R1 can handle much longer pieces of text, like entire documents. It helps it get a deeper understanding of complex ideas.
So not just sentences or paragraphs, it's absorbing information from, like, whole books.
Yeah, but it also uses sparse attention, helps it focus on the most important parts of the text for a given task, like a speed reader skimming for key information.
Working smarter, not harder. I'm seeing a theme here. Efficiency seems to be a big focus.
You got it. And that focus carries over to the alignment and safety measures, too.
Alignment, right. Remind me, that's all about.
Making sure the AI's goals match up with human values, being helpful, harmless, ethical. We want these tools used for good.
Got it. So how does DeepSeek R1 handle this?
It uses the standard RLHF, but takes it further with multi-stage alignment.
Multiple rounds of feedback, refinement from human experts.
Yes, it goes through several stages with human experts, making sure its responses are high quality and align with ethical guidelines.
Like editors meticulously reviewing the AI's work.
That's a great analogy. And to ensure fairness, reduce bias, DeepSeek R1 has special debiasing mechanisms built in.
Actively working to remove stereotypes or prejudice from the model.
Exactly. And get this, DeepSeek R1 actually evaluates and corrects its own responses.
Wait, the AI edits itself. That's amazing, like a built-in quality control system.
Yeah, self-reflection optimization. Make sure the output is coherent, logical, it's constantly learning, even without humans.
So not just generating text, it's thinking critically about what it's saying. Incredible. But with all these features, I'm guessing it needs a supercomputer to run.
And here's the thing, remember that focus on efficiency? DeepSeek R1 is actually designed to be pretty lean when it comes to computation.
Powerful, but not a resource hog.
Exactly. It uses things like low-rank adaptation and weight quantization to reduce the computational needs without sacrificing performance.
Okay, translate that into plain English for me.
Basically, they streamline the model, make it more compact, efficient, like taking a huge piece of software and optimizing the code to run faster.
So it can run on less powerful hardware. That's a game changer. It makes this kind of AI way more accessible.
Exactly. And that accessibility carries over to how DeepSeek R1 is used in the real world.
I'm all ears. How is it being used?
One key area is retrieval augmented generation, RAG for short.
RAG. Fill me in.
It gives the AI access to a huge external knowledge base. It can pull in information from external sources to give more comprehensive answers.
Like having a research library at its fingertips.
Exactly. And developers have a lot of control over DeepSeek R1's behavior thanks to fine-grained control mechanisms.
So they can tailor the responses for specific tasks, domains.
Yes, precisely. And here's another cool thing. DeepSeek R1 has a memory. It remembers past interactions, makes it much better at conversations.
So it's not just responding to each prompt on its own, it's building on the context.
Exactly. Feels much more like a natural dialogue. Like talking to someone who remembers what you talked about before.
Wow, DeepSeek R1 sounds really impressive, like the next generation with all the focus on efficiency, specialization, and safety.
It's a big step forward, and it'll be exciting to see how it continues to evolve.
Yeah, it's been fascinating. We've gone over a lot, the 5 stages of training, DeepSeek R1's unique approach, but one thing we haven't really dug into is how those innovations actually, translate into reduced costs.
Good point. The cost of training these LLMs, it can be a big obstacle, especially for smaller organizations, research teams, the ones without massive resources.
Right, it's a lot. Tons of data, powerful computers, the energy to run it all. It gets expensive fast.
Absolutely. DeepSeek R1's designers, they knew that. They built in some clever strategies to make the training more efficient, more affordable.
Okay, tell me more. Break down those cost-saving strategies for me.
One big one is that mixture of experts, MOE that we talked about.
Right, the specialized experts within the model, only activated when needed. It's like, what did we say? Like a team of specialists on call instead of everyone working on everything all the time.
Exactly. That targeted approach, it really cuts down the computational work compared to traditional models where everything's running all the time.
So it's faster and uses less energy.
Precisely. And less energy means lower costs. Another factor is the sparse attention.
Refresh my memory. How does that work again?
It's about being more selective. The model focuses on the most relevant parts of the text, not processing everything equally.
Like a speed reader, just grabbing the key info.
You got it. And that targeted approach means less computation, more efficient training, and cheaper overall.
So Mo and sparse attention, they're like trimming the fat, computationally speaking.
Good analogy. But there's more. DeepSeek R1 also uses things like low-rank adaptation and weight quantization during the training.
Okay, those sound a bit technical. What do they do?
Basically, they reduce the number of parameters that need to be updated during training. Imagine a huge control panel with tons of knobs and dials.
Each one representing like a different part of the model's behavior.
Right. With traditional models, you're constantly adjusting all those knobs for every piece of data. But with these techniques, you can streamline that.
So fewer adjustments, less complexity, less cost.
Exactly. All these strategies together make DeepSeek R1 remarkably cost-effective. It's a great example of how innovation can make these powerful tools more accessible for everyone.
It's amazing what they've done. But it makes me wonder, if DeepSeek R1 is already so advanced, what's getting next for LLMs in general?
That's the big question. LLMs are constantly evolving. The pace of innovation is just incredible. We're already seeing research on models that can handle even longer contexts, integrate better with outside knowledge, and generate more creative text. It's a really exciting time.
It feels like we're just at the beginning of what's possible.
I think that's a good way to put it. And as these models get more powerful, become part of our lives, it's really important that we understand them, how they work, the impact they have. That's why we do this show, to help people understand this complex and rapidly evolving technology.
Well said. And on that note, I think it's time to wrap up this episode of AI Podcast.
Thanks for joining us for this deep dive into LLMs.
Make sure to tune in next Monday for another exciting episode.